Okay, let's see here. If you're on, I apologize. It's my first time doing this, so I'm trying to figure it out. Let's see. Let's see here. Okay, hopefully this looks better. If someone could put in the chat that they're getting this and this looks okay, I'd appreciate it. There's a bit of lag on my end looking at it on Zoom, but we'll get going here in a second. Again, appreciate everyone's patience with this very first time trying a live YouTube live stream. So yeah, a new kind of circus for me. Yeah, if I could get someone to put something in the chat that says things look good. Okay, here we go. Sweet, I'm getting stuff. Cool. All right, so appreciate people joining and appreciate your patience again with this this live stream chat. I am not the Nick Zentner well-oiled machine or some of these other folks, but this is good. You gotta take a swing at the plate to hit a homer, right? So let's see how this goes. So a big event that happened last night, Sunday, about 11:30 p.m. Hawaii Standard Time, was the eruption of Mauna Loa. And this is a really significant eruption from so many vantage points. Historically, it's interesting because this volcano is the one that erupts the most often. If you actually look at the last, I think it's like 1,000 years of, maybe it's more than that, like 3,000 years of eruption data, including historic eruptions. Mauna Loa erupts about once every 6 years or so, which is pretty remarkable. And yet we haven't had an eruption there since 1984. And so pretty crazy that for, gosh, most of my life and maybe some other folks out there as well, we haven't seen this volcano erupt during that time. And during that time, we've seen Kilauea, which is Mauna Loa's kind of little brother here. And maybe we'll kind of go to the Google Earth image here. And then I'll provide some background here as well, but we'll be focusing on this volcano here. This is the one that just started erupting today. Let me give you a little bit more of the background of this eruption, and then I do have a progression of things I want to go through. Otherwise, my brain's just a little too scattered. So yeah, the eruption began last night at 11:30 local time in the summit caldera, which is called Moku Aweoveo. Hopefully I pronounced that right. And so the eruption began there and was initially confined to the summit caldera. And within the last few hours, about 7:30 a.m. local time, which was maybe, let's see, yeah, maybe a couple hours ago, basically, the lava has migrated into the northeast rift zone, which I'm going to talk about here. But this is significant for many reasons. One, just people who are interested in volcanoes like me, it's of interest. And certainly residents and visitors of the Hawaiian island, it's of interest. This poses a serious hazard to the residents of the island in terms of the infrastructure. We're not worried about this volcano causing any loss of life or anything of that nature. But this volcano has such a large breadth and reach that potentially this eruption, as well as future eruptions, have the ability to really impact in a significant way the infrastructure that exists there. So residents and people in the area should definitely be monitoring what happens there. But let's start with just kind of background. I don't know, I'm sure most of you are familiar to some degree with the Hawaiian Islands and their geologic setting, but just to provide some context for everyone, what we think is going on in the Hawaiian Islands is that there's a plume of magma moving its way through the Earth's mantle up towards the surface and feeding the volcanoes above it. And so you can see here we have the Pacific plate, which is moving off to the northwest. We have this plume of magma, which may be coming from, the upper portion of the mantle or much deeper. There's lots of unknowns about the hotspot, its origin, and some of the details and dynamics. But nonetheless, the model seems to hold sway, at least for now, that this mantle plume is feeding the volcanoes of the Hawaiian island chain. And so when we go over to Kauai, we see the volcanic rocks there about 5 million years old. And then they get progressively younger as we move towards the modern big island of Hawaii. So we've got Oahu here, 3.5 million years old, Maui, a little over a million. And then the big island of Hawaii is a baby. It's only formed in the last 700 or 1,000 or so years above the mantle plume. Presumably, as we move forward through time, this island, the big island, along with the others in the chain, will be dragged off of the hotspot or the location above the hotspot and will become volcanically inactive. And at that point, it'll be subject to the erosion of the rain and the waves, as is these other islands here, and will become much smaller in size. Right now, it's on this thermal heat source, so it's riding high. It has lots of young volcanic rocks as well that kind of add to its extent. And then a new volcano will sort of pop up in its wake. If we run back to our Google Earth image here and maybe zoom way out to get some context for where Hawaii sits in the Pacific Ocean, we can see through the water here and actually see a series of submerged islands and seamounts that extend northwest from Hawaii up here. And then there's an interesting bend here that changes the progression to more of a northerly chain. And then that ends up here near where the Aleutian chain intersects with the Kamchatka Peninsula of Russia. And so what's happening here is these are all ancient Hawaiian islands formed above the same hotspot that have been dragged over the hotspot and off of it, moving with the Pacific plate. And now they're about to be subducted or shoved beneath these younger continental plates here, part of the North American and Eurasian plate here up in this northerly portion of the Pacific. But when we look at the ages of these seamounts, they get progressively older to the north, progressively younger to the south. They have almost identical chemistries, and so they seem to therefore be of a common origin. And so here we have our modern Hawaiian chain, which are just the uppermost portions of these massive volcanic constructs that form on the ocean floor. And the Big Island is the biggest of the lot. And Mauna Loa is actually the biggest volcano, or among the biggest volcanoes. It's either one or two, depending on who you look to. But the biggest volcano on Earth by volume and mass. So this thing's just absolutely enormous. And if we switch over here to a diagram I made for the modern Big Island of Hawaii, we can see that the Big Island's actually made of 5 overlapping and coalescing volcanoes. We have Kohala to the north, which is the oldest volcano on the Big Island. This formed about 500,000 years ago, 700,000 years ago. It's considered extinct. It's extensively eroded. There's gullies in it. I don't remember off the top of my head when the last eruption was, but it's considered to be extinct. It's moved well enough away from the hotspot to no longer be active. Then we have 2 that are considered dormant, Hualalai and Mauna Kea over here. These are volcanoes that are probably past their primes. They could still erupt again. They're still connected to that hotspot to some degree. There's still reason that they could generate more magmas, but they probably, excuse me, we'll get back to that. They've probably done most of their damage already. Mauna Kea is also a really large volcano. It's over 13,000 feet tall, has telescopes at the top, and it's riddled with cinder cones. So it's what we call a late stage. It's past its shield building stage. It's already built up a shield volcano, and now it's dotted with these basaltic cinder cones that have slightly different chemistries. Hualalai over here is a shield volcano that's probably not as far along as Mauna Kea, and it didn't erupt as much material, so it's not as tall. But it's pretty much past its prime as well. And then we get to the other two volcanoes, Mauna Loa and Kilauea. And what I really want to point out here is just the absolute expanse of the island that is made up of Mauna Loa lavas and material. So everything you see in this zone here is made of Mauna Loa lava flows, mostly historic or slightly prehistoric in terms of age. And then Kilauea. And Kilauea is interesting because this is sort of the little brother that's just erupted in the last few thousands of years, and most recently from 1983 up to today, this thing's been the one that's been active. And I've had the fortune of visiting there several times with student groups, and we go to Kilauea and we can get down to the lava flows. Some of you might remember in 2018, it had an eruption. The magma moved away from this zone here, which is called Pu'uo'o, and moved down the East Rift Zone and started erupting in a neighborhood here, Leilani Estates, and formed lava flows that went all the way to the coastline, took out hundreds of homes, a real tragedy there, but also added some mass and some size to the island overall. So this is the volcano we typically think of when we think of Hawaii erupting. But this is the one we've kind of ignored it because it hasn't done anything since 1984. And as of today, Mauna Loa is reminding us who's in charge of this volcano and who the boss really is. So even though we still have a lava lake at the summit of Kilauea that's erupting right now, Mauna Loa is much larger. It typically erupts larger volumes of lava overall. It has steep slopes, so its lavas can move quickly down towards human infrastructure and homes. And so it poses a much bigger threat. There's more people and structures built on Mauna Loa real estate than there is on Kilauea. And so, it's human nature to kind of ignore the threat that's not in front of you. And Kilauea is the threat that's been more imminent for the last several decades. And now we're being reminded, unfortunately, of Mauna Loa's presence there. So I've got a couple of things I want to share with you. This is actually the webcam that the USGS has at the summit of Mauna Loa. This is looking towards the east, but you can see within the caldera there, as of this morning, 6:30 or so in the morning, their local time, you can see this lava lake. You can sort of see with the steam here, the fissures. You can actually see, I think these are some of the fissures erupting here. So this eruption began with a fissure cutting open the caldera floor and erupting lava within the caldera. And that's actually similar to what happened in 1984. It started at the summit caldera, but then it moved into one of these rift zones, which I'm going to show you here in a second. But let me also show you, this is a nice little loop that'll actually show the eruption when it begins. So here we are last night. And here we are at about 11:30, boom, there it is. There's the eruption and the fissure. I can't pause this, unfortunately, it's on a loop, but so here we are yesterday during the day, nothing's going on, just like for the last 38 years. And then night falls, and then around 11:30 at night, boom, this thing starts erupting, spilling lava. And you can see how much lava fills in this very large caldera pretty quickly. So it seems to be a pretty large volume of lava that's being erupted so far, although we haven't been able to quantify that yet. And so we should get more information from the USGS on that, hopefully pretty soon. This eruption did not come without some warning. So this did not catch us at all by surprise. We've had earthquake activity in this region for decades, but over the last couple months, it has escalated. And so the last a couple of months, since I'd say late September, there's been more frequent earthquakes beneath the summit of Mauna Loa, and also larger magnitude quakes. So this is just a map. You can't quite see the caldera under here because of all the dots, but the dot size corresponds to the size of the earthquake in terms of its magnitude, and then the color corresponds to the depth of the earthquake. So reds are very shallow, just beneath the Earth's surface. Oranges are a little bit deeper, and then you can see the progression there. So we had, a couple moderately deep quakes, and by that we mean, you know, a few miles down, but most of these are near the surface, and these are interpreted or have been interpreted as magma moving up towards the summit of the volcano, presumably starting to fill a magma chamber just below the summit there. So as that magma works its way through the rocks, it has to break the rocks. And every time the magma moves and fractures rock, that releases seismic energy through the crust, and that is what's detected as an earthquake. So the earthquake plots really tell us a lot about where the magma is or isn't, how it's moving, but it doesn't really tell us definitively if an eruption is going to occur or not. So we can tell maybe something's progressing towards an eruption, but there's also instances where the magma might move towards the surface, but then it kind of stagnates and stalls. And so there was no clear sign that this was definitively heading towards an eruption. Here's another plot just kind of showing a cross-section view of the map above. So you can kind of see where these earthquakes sit with depth. So yeah, a few deep ones, but mainly they're confined to the upper few miles or kilometers just beneath the summit caldera there. This plot here shows earthquakes over time. So the earthquake locations cross section, and then here's dates. So here we are back at Halloween, late October, marching through November. And then you can see there, you know, there's clusters in here, but it's pretty concentrated. There was definitely higher earthquake activity taking place over this period of time. And then boom, here we are, you know, last night and today with these larger events here. I believe the earthquake that preceded the actual eruption of the lava was about a magnitude 4, which again, sort of corresponds to the size of this this circle here. So, so that's some of the raw data from the USGS. Maybe going back to the Google Earth image, and let's look at these rift zones. And let me actually go to this real quick. So let me make this a little bigger. All the islands or all the volcanoes on the island have these things called rift zones. And what these rift zones are structural weaknesses. You can kind of think of these massive volcanoes, which are made out of basalt, which is a very dense rock. They become gravitationally unstable. Their sheer size and bulk makes them susceptible to these weaknesses. And so the orientation and geometry of these rift zones in large measure is determined by what neighboring volcanoes are kind of buttressing or sitting next to them. And so what we have then is we have some of these big volcanoes. Let's go with Mauna Loa. It has a southwest rift zone and a northeast rift zone. And that's because it has Kilauea to its southeast, Hualalai to its northwest, and Mauna Kea to its north. And so as this mountain has grown over time with progressive eruptions, it's actually started to slide or move very slowly towards the ocean, which is the only side that's not buttressed up against something, the side that has no construct there. So as the mountain has sort of slid this way, that's caused these rift zones to open up, basically a fracture. And this provides an easy conduit then for the magma to rise. And so Mauna Loa has 2. Mauna Kea actually has 3. Although this one's kind of small, and you can see the other ones there as well. Kilauea has a southwest rift zone and an east rift zone as well. So let me go back to Google Earth and kind of show you these as well. So here's the southwest rift zone of Mauna Loa and the northeast rift zone. And you can see with the obvious pattern of lava flows here, which are from the 1984 eruption. There was one in 1950. So early 1900s and late 1800s, that's mainly these kind of black and brown and gray zones you're seeing from Mauna Loa. But mainly the eruptions here take place either at the summit or in one of these 2 rift zones, or occasionally you can see one here that just kind of started not at the rift zone, but on the flanks of the volcano. These are called radial vents. And so the Mauna Loa has these radial vents that kind of just pop up. They radiate away from the main caldera and the summit. And you can see this radial vent here. I don't have the date on this one, probably early 1900s. Lava from this one, this provided enough lava that it flowed from, near the summit of Mauna Loa all the way down to the ocean there. So some of these can produce large volume flows as well. But Mauna Loa is a big mountain. It's over 13,000 feet tall. It was glaciated during the last ice age, but all the glacial evidence has been completely obliterated because it's produced more fresh volcanic eruptions and lava flows since that glacial period. You can see some of the glaciated evidence on Mauna Kea. There's striated rocks, there's deposits of till. It's pretty neat to go over there and check that out. But Mauna Loa, it has kind of cleaned the canvas every time it produces one of these eruptions. Let's see. So yeah, so we've got it's buttressed here to the southeast by Kilauea, to the north by Mauna Kea, and to the north or northwest by Hualalai. Couple things to point out relative to like the hazards and the ongoing hazards that might exist here. So the Southwest Rift Zone is probably the worst case scenario for residents of Hawaii because it's the steepest line of descent, and so had the magma moved out of the summit caldera and injected some of that magma into a lower vent along the Southwest Rift Zone, that could have meant trouble in a quick way. Because these lavas can move down to the highway and the coastline within a matter of hours. And unfortunately, we have residents living in this area. So if we go into this area called Ocean View, what you'll see here is right on top of some of these 1950 and slightly older lava flows, there's an extensive neighborhood. There's hundreds, maybe thousands, I don't know, of homes sitting either right on top of these 1950s lava flows, or in adjacent areas, there definitely are susceptible. And so right now, I got to believe that these people are hopefully paying attention to the news and what's happening with the volcano. Hopefully they are prepared to evacuate if and when it comes to that. But this is a scary situation for some of these individuals here. If we kind of cruise up the highway a bit, we can see there's some other little lava flows that have come down in the past. We've got other communities and towns and little villages that are kind of built up that are in harm's way, depending on exactly where lava erupts from this volcano. Fortuitously, so the biggest community of people on this side, the dry side of the island, the leeward side of the island, is Kailua Kona. And so Kailua Kona, which has a major international airport, luckily is actually shielded from Mauna Loa volcanoes. Mauna Loa volcanoes cannot get into this region in here because they're protected by the bulk and the mass and the height of Hualalai. So here's Hualalai and some of its summit cones and vents and craters up here. But this volcano is actually protecting this area from eruptions. But nonetheless, an eruption of Mauna Loa would be bad for everyone on the island because we could have some of these highways cut off, and there's only so many ways to get from the east side to the west side of the island. There's Highway 11. There's the Saddle Road here, which cuts through between Mauna Loa and Mauna Kea. Right now, this highway looks to be the most threatened based on what's happened today. And then there's another highway that goes up to the north, Highway 19, along the northeast side of the island, the windward side of the island. But yeah, so lava flows are probably the primary hazard that we're looking at right now. There is, if a good source of information is if you get on the USGS Volcanoes Facebook page, they have a great crew that works tirelessly around the clock when things like this happen to provide updates and answer questions on social media. So this might be a really great resource to you. In fact, if I update it, who knows if I'll get any quicker information, but it looks like they've already got crews up there. So here's a panoramic shot. There's some lava in the background and one of the USGS scientists there. I have a buddy who used to work there at the HVO. He now works for Alaska Volcano Observatory. Pretty awesome. But here's two photos from a flight they took this morning once the sun came up and it was safe to fly. Here's a couple photos showing the lava flow. So this is probably looking, I would guess this is looking to the east or southeast, and this is lava from these fissures coming out of the northeast rift zone and flowing down to the east. Right now, the slope on the northeast rift zone is much more gentle than the southwest side. And so the flows aren't moving as fast as they might if they were on the southwest rift zone. So that's a good thing for residents and infrastructure. Luckily, the northeast rift zone has no, other than the highway, there's no communities here. There's no homes for the most part that I'm aware of. A lot of this was actually a testing ground for the military. So you might see a few buildings in here that are old military constructs. So let me move back to this. Yeah, so there's that photo there. And then this photo, this is a nice photo here. So this is looking more or less due north. There's Mauna Loa, just under the plane wing. We can see looks like it's topped with clouds, but it might have a little snow on it this time of year. You never know. It does get snow up there. And we can see some of the lava flows encroaching to the north, headed towards the highway, which is presumably way down here. So still early to say exactly how this is going to go. The 1984 eruption was notable because it actually produced lava in the summit that moved into the northeast rift zone. And the lava, over the course of 3 weeks, you can see some of these eruptions here, where the flow fingers coming down. It got within about 3 or 4 miles of Hilo, and luckily the lava supply waned, it stalled, it stopped, and the eruption ended. But there was people in Hilo that were very nervous in 1984, thinking about if these flows were going to progress all the way into town. And so, again, too early to hit the panic button. This thing could fizzle out within hours or days. It might last weeks. It could last longer. But we're definitely in a newer phase in terms of eruption activity in Hawaii. We've been focusing on Kilauea for the last 38 years. All the activity in Kilauea has either been its summit area, where it has a lava lake here today, or its east rift zone, which extends down this way through these craters. And these lava flows, or these events, and most notably Pu'uo'o, which is here, have fed lava flows that have traveled down the slope to the southeast and into the ocean. No infrastructure here for the most part. We did have in the 90s some homes and a visitor center in Kalapana that was impacted. But by and large, most of Kilauea's damage the last 38 years has been pretty minimal, thanks to just not having a lot of infrastructure in this area. Of course, that all changed in 2018 when the magma from Kilauea moved further down the East Rift Zone and started erupting in this neighborhood here called Leilani Estates, formed a fissure. You can sort of see the line of fissures here. Eventually, that sort of concentrated the lava into one specific cone. I believe it was called Vent 8 or something like that. We built up a nice big cone there, and that fed lava flows, which went in a bunch of different directions, but ultimately to the east and to the northeast, and completely took out what was once a community here. So I can show you what this looked like prior to it. So I've, again, been lucky enough to go there with students. So if we go back to, here we are in 2010, these are just clouds here. That's not eruption, but 2010, you can see this beautiful, this is Kapoho Bay. So this is a bay we used to take students snorkeling there. Lots of homes and vacation homes in this area here. So this was just 2010. We could even get it up to maybe like, here's 2017. So here's just 5 years ago, what this area looked like. And then, sorry, I just changed the view a little bit there for you. And then what it looks like today with the lava. Those homes are just completely gone. So 2017, 2022. So, you know, the volcano sort of gives and it takes away. Having spent some time in Hawaii, the natives and residents there are well aware of this. It's something that they willingly accept, that they live on this beautiful dynamic island with these active volcanic processes. So it's pretty crazy. That's all I have for right now. I'm going to look through the chat and see if there's any questions people have that I could address. Maybe you've answered your own questions. I'm really just glad this worked out. First live stream wasn't too hard once I kind of got past it all. Let's see, just see people, some people are actually in Hawaii, or, oh, someone drank, they drank some Kona coffee. Yeah. Yeah, Mauna Loa is huge. How many of them are active? So officially, we just classify Kilauea and Mauna Loa as being active. Hualalai and Mauna Kea, also on the Big Island, are considered dormant, meaning they could erupt again, but we think they're kind of past their peak phase of activity, but an eruption there would not be completely out of the question. Kohala up here is inactive. If we move up to Maui, the only active, well, or potentially active volcano is Haleakala. So Haleakala, which is a big mountain over 10,000 feet tall. I don't remember off the top of my head when the last eruption at Haleakala was. Look that up. But that's also considered a dormant volcano. And remember, the way that geologists consider volcanoes active is a little different than what just people in popular culture might. Let's see, anything else? I'm just scrolling through the chat to see if you have, how many million years ago did the Hawaiian volcano chain make that big 90-degree bend in the Pacific? Okay, Sharon, good question. I don't have that off the top of my head, but I'll give you a good ballpark number, and then you can go sleuth that on your own and hopefully find it. So what she's referring to here is we have this nice progression of volcanic islands and submerged islands, what we call seamounts, these sort of flat-topped constructs here. Once these islands get pounded by the waves and the rain, they tend to be somewhat kind of preserved beneath the ocean surface. So they form these kind of flat top or flattish top plateaus here. They look kind of funny on Google Earth, but this is, only, a couple hundred feet below sea level. Sometimes they form reefs. They're so shallow that they form reefs like we have here, or they form these other things called atolls. But to get to your question, the bend here, I believe, is at about, I want to say like 35 to 42 million years old is about the age when the bend took place. And this bend is interpreted as a change in the plate direction. So presumably the Pacific plate was moving to the north for some X number of million of years. And then at about 35 to 42, whatever the age of this elbow is here, it changed to moving more northwesterly. And you can see that in other, let's see if I can find, there's other volcanic hotspot chains. I probably won't find any in here. I know they're more in the South Pacific that also kind of show that bend and that progression that you might be able to kind of spend some time hunting around on Google Earth for. But that's at least how it's been interpreted, is that bend representing a change in the plate direction. Yeah, someone said about 50 million years, could be. Look it up. And yeah, testing in the area north of the flow, and I agree, that's what that Saddle Road area, that's probably why there hasn't been a lot of development there, is it's either owned or somehow annexed by the military. So yeah, I'm glad this works so well. How do mantle plumes form and reach the surface? Oh boy, there's all sorts of ideas and models for that. We're not even sure where mantle plumes originate. We've got to give geologists a little bit of slack here because we're trying to answer questions that are originating literally, hundreds of miles beneath our feet. It's hard to get data from that region of the Earth, and interpreting the seismic waves and their characteristics is sort of the best we can do. So why we even have mantle plumes? Really good question. Some people think they might represent subducted slabs that the hot rock, it gets deflected around a subducted slab and then reaches the surface. I'm sure there's some other models or hypotheses for mantle plume origins as well. I don't know off the top of my head. Yes, people happy to live on a stable continent. Yeah, but you never know. Yeah, Haleakala. Yeah, I think that's it. Appreciate everyone jumping on here. Hopefully this was helpful. I'll figure out how to make this available to other folks. And definitely if something exciting happens at Mauna Loa or some other place where I feel like this is a good format to dispense some information and share what little bit I can, I will. Again, this is kind of exciting and important to me because I'm slated to take a group of students to the Big Island in May of 2023, so in 6 months. And so this will possibly drastically impact, well, one, our travel plans, but two, exactly what we can see. So I'm excited that maybe I can get students to be able to see and witness and observe some of these processes up hand, but I'm also a little leery of like, well, are the highways going to be closed and can we not get into some areas? I was in Hawaii in 2018 when this eruption took place over here off the East Rift zone of Kilauea. And I don't know how much of this I should admit. They had some of the roads closed. I was not with students. That's probably the first thing I should say. I was with my family and I just really wanted to get in and see. So at that point, it was mid-May of 2018. The flows hadn't reached the ocean yet. It was mainly just erupting in Leilani Estates. And I really wanted to like sneak in here and get close, but it just didn't work out. So the best thing I could do was I took a helicopter tour over the volcano when it was erupting, and that was really exciting. In fact, we were probably a couple thousand feet above the ground and you could still feel the heat coming off that lava flow. At that point, it was feeding, I guess it was feeding this flow because we flew, maybe it was going to the ocean. It was, I take that back. It was actually going this way and down to the coast because the helicopter took us near the coast and we could see the big steam plume. But we flew over this lava channel through here at whatever altitude in a helicopter, in an open helicopter, and you could just feel the heat radiating upwards from that lava flow. It was just really impressive. So I'd hoped to have been on the ground and see it in person, but that was the best I could do was that. So we'll see what happens. Yeah, if anything else happens with Mauna Loa that's significant, I'll try to provide an update. There's obviously other places to go for this as well. I know you guys have lots of choices and options in where you get your information, but I do appreciate it. It's fun just to interact with people. It's kind of an extension of what I do here at the college with my students, and you guys are a much more captive audience. I spent the first 15-20 minutes of class this morning in my physical geology class telling them about it, and it was hard to read their expressions as if they really thought it was that exciting. They just sort of looked blankly ahead, and there was a couple questions, but not a lot. So probably not as excited about it as I am or you are. So I'm going to look at the chat one more time, make sure there's nothing I'm missing here. Is there any info on how much magma is spilling out in cubic meters? That's a great question. I'm sure the USGS will quantify over the next day or two as best they can the volume of lava being pumped out of the ground. That will be really important because that will give us ideas and projections on how quickly what they can actually do is take that volume of magma that's erupting and take a detailed topographic model of the surface and come up with good estimates for how quickly the lava will move through that topography, the path it will most likely take, and get some time components on like when it might reach the highway or towns or whatnot, just depending on how much magma is coming out. Of course, the volume of magma can change. And that's the big unknown is like, okay, it's erupting, but how much magma is it going to erupt? Is it going to erupt a large volume in a short period of time? Is it going to be more sustained? Is it going to be over in a day or two? And those are the things that we just don't have the tools to be able to handle. So let's see. I don't think that's it. Yeah, new lava babies. I wish I was there to help deliver a basalt baby in Hawaii. That would be really cool. How dependent on Big Island are the rest of the Hawaiian Islands? Not sure what that one is asking. Oh, like maybe for infrastructure, like, yeah, in terms of like the economy and stuff, I don't know, like in terms of like things they grow. There's a lot of cattle ranching on the Big Island. There's obviously a big coffee industry, different produce, bananas. There's lots of things grown. Obviously not on some of these older flows, but in some of the lowland areas that are wetter and more where there's more soils. Really good question there. Last little scroll here, and then we'll sign off. Yeah, it looks like someone says that the elbow in the Hawaiian seamount chain is around 40 million years old. That's pretty close to what I had, so I guessed. Yeah, we don't know how much magma is coming out. We're going to have to figure that out. That's something to be discovered soon. What kind of lava is it? Full of gas, or is it just a sludged liquid? The lava, this is basaltic lava, so it's low viscosity lava, which means it's runny. It does have some dissolved gases in it, but because the lava is somewhat runny, the gases can escape easily and quickly and just go up into the atmosphere. They don't get trapped, and therefore this is not an explosive volcano. That being said, there is a chance that the eruptions near the summit and these fissures will produce some tiny particles of ash, which would drift with the trade winds, which come from the northeast and go to the southwest. So there is some possibility that air quality would decrease for these downwind communities. There could be higher concentrations of ash in the atmosphere, which could pose health hazards to vulnerable populations potentially. That's all kind of a wait and see thing. But yeah, I guess calling it a sludge liquid, I love that term. That would be probably more appropriate to what it is right now. So any idea how long it would take for a lava flow to cool enough to rebuild a road back over it? Yeah, the lava stays hot for quite a while. Rock is really good insulator. I've even been out on flows. Let's see, 2014, where the heck were we? 2014 was the year there was lava that was coming off of Pu'uo'o and moving towards Pahoa. And we had a local, it's kind of sketchy, but it was super fun. We parked somewhere over in here, or maybe we were on some back road somewhere. Anyway, we hiked through this muddy forest and got out to these flows here on Kilauea. And the flows there were probably a few weeks old, but they were still hot. In fact, hot enough that you could feel it with your hand, and hot enough, not just that, but I even told students, I'm like, hey, don't sit down, because if you sit down and sit for too long, there's a chance the heat from the rock could burn a hole in your pants. I don't know if that was true, but it felt like it could be true. And so we just kind of stayed on our feet and moved around frequently. So it can take quite a while for the flows to cool and solidify, probably weeks. Rebuilding the road, gosh, they would have to be really sure that there wasn't going to be another eruption sometime soon. A good example of that is there used to be a road down here. Here's the Chain of Craters Road coming off of Kilauea, and you can see here where this road dead ends right there. So these flows here from 1983 through the 90s and early 2000s have taken out this section of coastal road. And as of now, they have not, as far as I know, they've not rebuilt that, or at least repaved it over into Kalapana. Similarly, some of the 2018 roads that were wiped out over here, I'm pretty sure, I'll have to check, that they have not completely rebuilt some of those roads. So there's sort of two questions. When can you rebuild the road, technically, logistically, and then when does it just make sense? When are you sure, you don't want to rebuild the road and then have a lava flow 2 months later come in. Do we need to worry about a slide generating tsunami? Okay, that's actually not very likely, but there is the potential with eruptions at Mauna Loa that, so if we zoom way out, you can see away from all the Hawaiian Islands are these just masses. Here's the perfect one over here. This jumbled chaotic block of material. are landslides, huge undersea landslides that have emanated from either Molokai or from, in this case, Oahu, that moved out, you know, tens or hundreds of miles out across the ocean and would have generated massive tsunami. I know they've dated these. They're thousands or hundreds of thousands of years old, or maybe even older than that. But the point is that these big, huge volcanoes built out of these massive, dense rocks are gravitationally unstable, prone to infrequent but sudden and huge collapses. And so all this bumpy ground you tend to see in the below the water level around the volcanoes, a lot of these are actually landslide blocks and big chunks of material that have slid down off of it. So if you have a condo on Diamond Head, I wouldn't worry about it right now, but you should probably just, you know, I don't know, always, like, you have a hazard there, so you should make sure you're kind of educated on that as best you can. How fast is it moving? Don't have any data on how fast the flows are moving. Based on the photos we saw here, these are nice, smooth, ropey Pahoehoe flows. They're probably moving, here's just a ballpark guess, maybe 100 meters, 100 yards or so, maybe every couple hours. So not that fast. They're not moving like, you know, 20 miles an hour or something like that. These are probably moving 100 meters, maybe within an hour, but probably a little bit slower than that. Yeah, someone said, yeah, the caldera is filling, right? So the caldera could fill up completely. Yeah, it happened in Iceland. Yeah, good stuff. Yeah, thanks everyone. And I'm sure there's other places to get this stuff, but I appreciate you coming here and getting my take on it. I'm no expert, but I do know the Hawaiian volcanoes pretty well, having visited there several times and just doing a lot of volcanology research and coursework and that sort of thing. So I'm going to go ahead and shut it down, but I appreciate everyone for jumping on, and have a great day from what is a snowy southern Idaho. We got a couple inches of snow last night, but I'll be watching the lava just like you, and we'll hope that it doesn't adversely impact our fellow citizens in Hawaii, but we'll watch with interest because volcanoes are always something we can learn from. So